Hello everyone. We're going to now continue on to problem 123 from section 4.3. Again, we're trying to find absolute maximums and absolute minimums on a given interval. So here we've got y equals x plus sine x over the interval 0 to 2 pi, and I wanted to quickly graph this. So we'll go to the TI, and I've already graphed it from 0 to 2 pi. And maybe I'll just pick a different window so we can see it a little bit better here. And here I'm picking 0 to 2 pi, 0 to 2 pi. So be a nice square window, although it is a rectangle. So we'll go ahead and graph that. And notice at the left end of the interval at 0, it definitely has an absolute minimum just from the graph. And at the right side of x value of 2 pi, it definitely has an absolute maximum of 2 pi. So just from intuition from the graph, it does appear that 0, 0 would be the absolute minimum, and 2 pi comma 2 pi would be the absolute maximum. And over here, maybe there's a local maximum here, maybe a local minimum. It's kind of hard to tell. I guess we could zoom in on that. But let's go ahead and just look at the equation itself. So here's our equation, y equals x plus sine x. And we'll go ahead and take the derivative to find critical numbers. So for the critical numbers, we first need the derivative, and so y prime is going to be 1 plus cosine x. And that function definitely is well defined over the interval 0 to 2 pi. So the derivative won't go undefined. So now to find a critical number, we'll just set that to 0 and solve for x. And so we quickly get cosine of x equaling -1. And if we recall the unit circle, the horizontal position on the unit circle that is -1 is right over here, and that angle is pi radians. So here x is going to be pi. So to test for absolute maxes and absolute minimums, we need to look at the critical numbers and the endpoints. So we'll look at y at 0, y at pi, and y at 2 pi. 0 and 2 pi are the endpoints of the interval, and pi is the critical number. This is simple enough. We can just input this into the equation. When you input 0 into the equation, you get 0 plus sine of 0, which is 0. Inputting pi into the equation, you get pi plus sine of pi, which will be pi. And inputting 2 pi into the equation, 2 pi plus sine of 2 pi is 2 pi. So by inspection, 0, 0 is the absolute min, and also by inspection, 2 pi, 2 pi is the absolute max. Notice that pi is a critical number for an x position, but it is not a local extreme. It's not going to be a local max or a local minimum. If we look at the number line, and I'll put pi in the middle of my number line here. When I look at the derivative, at pi, it's 0. Let's just go to the right of pi. Let's check 3/2 pi. So I'll put it as a test value, 3/2 pi. And if I put this into the function cosine of 3/2 pi, well, if I look at that on the unit circle, I've got the unit circle up here. 3/2 pi is down here. The cosine of it's going to be 0. So this will be 0 on this side, and it's the derivative. So that's 0 there plus 1. So This will be bigger than 0 to the right of pi. And to the left of pi, let's say we'll look at y prime at pi halves. See if I can get this to move here. A little finicky there. And at pi halves, the cosine of pi halves is 0 again, and 0 plus 1 is 1. So notice that the derivative is positive. At pi, it goes to 0, and then it's positive again. And so it doesn't actually change. It's increasing, increasing, goes to 0, and then increasing, increasing. So again, if we look at the graph here, here's pi right here. Increasing, 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 now the derivative is 0, increasing, increasing because the derivative is positive. So on either side, it doesn't go from increasing to, say, decreasing. That would be a negative derivative. And also it doesn't go from decreasing to increasing. And so on the calculator, as well as looking at the actual graph here, we can see that pi does not result in a local minimum or local maximum. So we have absolute minimum at 0, 0, and absolute maximum at 2 pi, 2 pi.